We begin in a quiet, ancient world, one so calm and understated that even the concept of crowded has not yet been invented. The oceans are vast, unbroken expanses of water, drifting under skies untouched by birds, clouds, or any noise louder than the slow conversation between tide and shore. Here, life is present, but only in the gentlest sense. Soft-bodied creatures floating in the dim light. Tiny clusters of cells feeling their way forward without any ambition beyond continuing to exist. Nothing resembles a herd or a flock or even a polite gathering. Survival at this stage is a strictly personal hobby. In the quiet sweep of Earth's deep history, survival was never a solo endeavor. From the first accidental gatherings in ancient seas to the tightly bonded herds that roam our world today, life has been shaped by the simple power of staying close. Hello there, and welcome to the Late Night Scientist channel. Tonight, we'll drift through millions of years as group living evolves, slowly, gently, into one of nature's most successful strategies. Settle in, breathe deeply, and let the story of herds unfold around you. A journey where danger softens, landscapes shift, and continuity triumphs not through strength, but through togetherness. The earliest multicellular beings occupy their environment with quiet certainty. They drift because drifting is the simplest motion. They cling because holding on is easier than letting go. Their bodies are uncomplicated little experiments, layers of cells arranged in patterns that barely qualify as plans. They have no brains, no nerves, no sense of a world beyond the immediate touch of the water that surrounds them. If asked about their goals, they might respond, if they could respond at all, that they intend to keep being exactly as they are. Danger in this era is not a dramatic affair. It does not leap from shadows or prowl in silence. Instead, it arrives in the form of chemical shifts, subtle currents, or a neighboring organism drifting just a little too close. Threats are vague, almost philosophical. A change in temperature, a shortage of nutrients, or the possibility of being accidentally consumed by something that hasn't yet developed the courtesy of intentional feeding. Even so, the world is not hostile, only indifferent. Life survives not through competition, but through persistence, the slow and steady conviction that continuing for one more moment is enough. These early animals, if animal is not too generous a term, exist without the faintest trace of social intention. They do not recognize each other, nor do they need to. The idea of forming a group would be as unimaginable to them as flight would be to a stone. They do not seek comfort, companionship, or collective protection. Each organism moves through its world alone, not because solitude offers advantages, but simply because no alternative exists. Cooperation has not yet been invented. Evolution is still preoccupied with establishing the basics, inside versus outside, up versus down, and yes, left versus right. The environment reinforces this pattern of solitude. Resources are scattered lightly across the ocean floor and suspended in the water column. abundant enough that competition barely rises to the level of inconvenience. When food is everywhere and danger is nowhere in particular, the incentive to gather does not emerge. These organisms float through nutrient-rich waters that feed them indirectly, like a buffet that walks to you instead of the other way around. Life at this stage does not demand strategy, only patience. Yet within this quiet, something remarkable is beginning. The first experiments in sensation appear. A patch of cells becomes faintly responsive to light. Another develops a rudimentary sense of touch. These small innovations create the earliest whispers of awareness, a kind of biological curiosity. Though they lack nervous systems, these organisms begin to perceive their world in ways that hint at future complexity. A dim glow above means warmth. A shift in current suggests movement. Still, these sensations are deeply personal experiences, not messages to be shared. There is no one to warn and no reason to try. As bodies become marginally more capable, their interactions with the environment grow more intricate. Some flatten themselves to increase their surface area, gathering nutrients more efficiently. Others develop simple cilia, waving gently to propel themselves along the sea bottom. Even these innovations do not change the fundamental solitary nature of early life. Motion brings them no closer to each other in spirit or purpose. It only allows them to occupy new patches of ocean in which to be alone. At this stage in evolution, solitude is not a disadvantage. In fact, it is astonishingly effective. With limited senses and minimal vulnerabilities, these early creatures live in relative peace. No predator hunts them with intent. No competitor steals food deliberately. The world is too young for conflict to be anything more than accidental. In this gentle balance, life thrives by minding its own business, an evolutionary strategy so understated that later animals would never believe it once worked. Among the earliest innovators are organisms that begin forming colonies. But even these are not groups in any intentional sense. They are clusters of cells that remain physically attached because it is more convenient not to separate. The cells do not communicate. They simply coexist. Over time, these colonies hint at the structural foundations of future multicellularity, where different cells take on different roles. But for now, complexity is still an unintentional side effect of sticking together, not the product of cooperation. Across millions of years, the ocean gradually fills with a greater diversity of forms, each exploring the possibilities of shape and function. Still, none of them gather in herds, schools, or swarms. The idea of us has not yet entered biological vocabulary. These organisms remain unaware that life could ever be anything but solitary. Yet by simply existing, they set the stage for everything to come. Because evolution, in its patient, meandering way, is slowly discovering that a world full of solitary creatures is only the beginning. It is crafting bodies, testing ideas, and gently preparing for the day when life will stumble into a revelation. That sometimes survival is easier when someone else is nearby. But for now, in these quiet, early seas, evolution hasn't considered teamwork yet. It's still busy inventing left and right. The Cambrian oceans arrive like a sudden inhalation, one great planetary breath that fills the seas with life thicker and more varied than anything the world has ever held. What was once a quiet expanse has become a slow, shimmering traffic jam of creatures testing out new body plans with a kind of evolutionary enthusiasm. Some develop shells, some grow spikes, and some, for reasons known only to evolution's sense of humor, decide to reinvent the concept of wiggling in 100 different ways. The water is no longer empty. It is gently bustling. In this growing density, animals encounter one another far more often, and not because they intend to. They are simply running out of room to be alone. Soft-bodied swimmers glide alongside segmented crawlers. Trilobites amble in loose clusters. Worm-like creatures burrow under one another, with the resigned patience of commuters in an overcrowded station. The Cambrian world is not yet social, but it is undeniably shared. These organisms do not recognize companionship. They do not seek comfort or align themselves with others for emotional reassurance. What they do recognize, if recognize is not too generous for their nervous systems, is that the environment has changed. Food patches attract multiple feeders. Rocky crevices shelter more than one body. And where one animal finds safety, another might quietly join, not out of trust, but because the physics of space now encourage it. Here in these lively seas, the first hints of accidental clustering appear. A group will form simply because several individuals happen to be grazing on the same microbial mat, each nibbling on its patch while pretending not to notice the others. Another cluster emerges when currents gather drifting creatures into the same trough or along the same reef wall. These gatherings have no structure, no intention, and no coordination. They are the biological equivalent of arriving at a quiet tide pool and realizing it is already scheduled to host a convention. Predators, newly sleek and inventive, begin to test their strategies in this more crowded arena. Some are swift, others are patient. All of them are thrilled by the increased number of targets. Yet even they face a new challenge: too much choice. When prey animals move in loose, scattered groups, little chance gatherings rather than deliberate formations, the predators find themselves momentarily overwhelmed. Which one to chase? The slow one? The plump one? The one that looks like it might fall apart if nudged? A moment of hesitation is all it takes. The prey scatter with the clumsy grace of animals who have never practiced coordinated escape but know an opportunity when they see one. And thus, entirely by accident, the earliest advantage of proximity appears: confusion. Not a planned strategy, but a fortunate side effect of being in the wrong place at the same time in just the right way. Predators learn, somewhat begrudgingly, that chasing one meal is easier than choosing from a moving buffet. The Cambrian seas are filled with peculiar innovations that make these interactions increasingly dynamic. The first compound eyes gleam like jeweled mosaics, detecting motion in quick flashes. Jointed limbs allow for sideways scuttles and sudden darts. Flexible bodies ripple through water in elegant S-curves. These new sensory and locomotor abilities not only help organisms survive, they increase the likelihood that one creature will bump into another, notice another, or blunder into the same feeding zone. Life is becoming observant, whether it wants to or not. Among these shifting dynamics, certain animals begin to follow gradients in the water, chemical hints that say, in essence, food is this way. When several creatures read the same signal, they converge without meaning to. The result is an early form of collective movement, not coordinated, not synchronized, but undeniably shared. Many bodies drift in the same direction, like a procession with no leader and no real purpose beyond, "This seems promising." Some of these assemblies persist for minutes, others for hours. Consistency is not the point. What matters is that these gatherings expose organisms to a new kind of environment, one where nearby bodies shape the flow of water, alter the distribution of food particles, and obscure visual cues. A creature that once navigated by simple sensory rules must now adjust those rules in real time, its world filtered through the swirling presence of neighbors that it neither seeks nor avoids. In this increasingly complex water column society, even sediment becomes a shared experience. Burrowing animals disturb the sea floor, sending plumes of nutrient-rich particles upward. This attracts other feeders, which attract still more, each one settling into the cloud of opportunity created by the last. What looks like a group is actually a chain reaction of responses, each animal tugging subtly on the behavior of another. There is no cooperation here, only parallel instincts intersecting by chance. And yet, these chance intersections matter. They shape the flow of evolution in ways none of the participants can understand. A predator's hesitation favors prey that happen to linger near others. Prey that feed near one another unintentionally churn sediments more effectively, influencing which species thrive. Even the simple act of bumping into a neighbor may nudge an organism to drift a different direction, altering its fate in small but meaningful ways. Life at this point in history is not social, but it is beginning to experience the consequences of being surrounded by other lives. The oceans feel fuller, more alive, more unpredictable, and more interconnected than before. Though no creature intends to cluster, the seas gently encourage them to do so, like a host who keeps placing chairs just a little too close together. And so the first unwitting gatherings form, not herds, not swarms, but the faintest hints of togetherness born from nothing more than density and motion. Evolution does not yet favor teamwork, but it is starting to notice that when bodies overlap, new possibilities emerge. In the ancient seas that follow the Cambrian bloom, life becomes more alert. Eyes sharpen, bodies streamline, and nervous systems grow just complex enough to interpret the world in increasingly immediate terms. The ocean that once felt like a drifting mosaic of organisms now pulses with motion, tension, and quick decisions. This is the age when early vertebrates, equipped with new sensory tools, begin to understand something revolutionary. Danger is not simply a moment, it is a message. These first vertebrates move with an intent unfamiliar to their predecessors. They have muscles arranged in ways that allow swift, coordinated motions. They possess spinal cords that shuttle signals far more efficiently than diffuse nerve nets ever could. Their eyes, more sophisticated than the light-sensitive patches of earlier creatures, detect approaching shadows, flashes of movement, and the glint of a predator's advancing form. They can distinguish direction. They can interpret speed. And most importantly, they can react with urgency. For the first time in Earth's history, fear is no longer a personal sensation. It is a transmissible event. Picture a small fish-like creature gliding through the water, gently oscillating its tail. Its world is a shifting tapestry of glimmers and drifting particles. Then, suddenly, it perceives something unfamiliar. A ripple traveling too fast, too steady, too purposeful. In an instant, without analysis or deliberation, its body folds into flight. A rapid flick of its tail sends it darting into safer water, its escape reflex acting several times faster than thought. And nearby, another animal, one that never noticed the threat, sees only the sudden burst of motion and runs. This second creature has no idea what it is fleeing. It has no reason to believe that anything is wrong. But the swift departure of a neighbor triggers the same cascade of reflexive signals. The pattern is simple. If someone bolts at top speed, it is best to assume they have a reason. And so fear spreads, leaping from one set of muscles to the next in a chain reaction of instinctual escape. Survival now moves through communities of animals in widening waves, as fluid and pervasive as the currents themselves. This phenomenon is not cooperation, not yet. It is not communication either, because nothing is being intentionally shared. Instead, it is the birth of something subtler: behavioral contagion. Fear becomes the first emotion to ripple outward through a group, not because the animals care about one another, but because following someone else's panic is reliably safer than staying to investigate what caused it. Better safe than swallowed, evolution whispers, drafting a rule that will last hundreds of millions of years. Meanwhile, predators adapt to this new emotional landscape with mixed results. The ambush predators, sleek and predatory in silhouette, are startled to find their carefully stalked meals vanishing before they even arrive. The pursuit predators discover that a sudden, synchronized burst of fleeing prey is harder to follow than the steady movement of a single victim. A predator may choose a target, accelerate toward it, and then watch helplessly as the entire crowd erupts into motion like a school of startled sparks. The hunter's hunger remains, but the certainty of success begins to erode. In these moments, evolution quietly reinforces the advantage of being near others, not for companionship, but for unpredictability. A solitary creature reacts only to what it perceives. A small cluster, however accidental, reacts to a collective amplification of information. One startle becomes 10, 10 become 50, and the predator finds itself chasing an ever-shifting cloud of bodies, none of which remain stationary long enough to catch. Fear, it turns out, is extremely contagious, and evolutionary history will never let it forget that. This spreading of alarm influences more than just the dynamics of predator and prey. It begins reshaping the very way vertebrates sense and move. Those that respond more quickly to the sudden acceleration of a neighbor thrive. Those with better peripheral vision gain a new advantage. Those whose muscles twitch at the slightest cue pass on their genes in greater numbers. Over thousands of generations, a refined sensitivity to the behavior of nearby animals becomes a quiet prerequisite for survival. In this era, no creature plans to act as a lookout, but some inevitably do. Individuals positioned near the edges of loose gatherings are more likely to spot predators first. Their sudden reaction, unintentional though it is, saves countless others. These first responders are not chosen, honored, or thanked. They simply happen to be standing where danger appears first. But their reflexive flight sends a message into the group, one powerful enough to redirect the path of evolution itself. The water becomes a realm of sudden bursts, scattering trails of silver, streaks of motion reflecting sunlight in chaotic patterns. Each burst tells a story the participants may never fully comprehend, yet all of them obey its implications. In these early vertebrates, awareness extends beyond the body. The movements of others become extensions of one's own sensory system. A neighbor's twitch becomes a warning. A sharp turn becomes an instruction. Survival becomes partly outsourced to the behavior of the group. Still, none of this is social structure. These creatures do not huddle or plan or coordinate. They continue to live independent lives, coming together only through the geometry of chance and dispersing just as easily. But there is now a new thread woven through the fabric of their world, a faint, trembling line of connection that ties one life to another through instinct rather than intention. And sometimes, as entire assemblies of vertebrates fling themselves away from a threat none of them manage to see, a comical truth reveals itself. Nobody knows what's wrong, but everyone agrees it's time to leave. In this shared, unspoken agreement lies the earliest seed of something that will eventually become group behavior. Not loyalty, not strategy, not unity. Just a simple, powerful understanding that when fear moves, it is wise to move with it. The first hesitant ascent onto land is not a triumphant charge, but a slow, uncertain testing of boundaries, an evolutionary toe dipped into an unfamiliar world. The shoreline, once merely the edge of possibility, becomes a threshold crossed by creatures who neither intend to conquer new territory nor revolutionize life on Earth. They are simply following opportunity. Pockets of food concentrated in shallow pools, strands of decaying vegetation rich in nutrients, or warm mudflats offering temporary refuge from aquatic predators. But once they pull their weight onto land, they discover a truth no water dweller could anticipate. The world above is dramatically inconvenient. Gravity, for instance, introduces itself with surprising enthusiasm. Limbs that served mostly as paddles or stabilizers in water now bear the full burden of a body. Movement becomes deliberate, each step an experiment in balance. The ground does not cushion, it demands effort. Muscles adapt, bones strengthen, joints articulate more decisively, all in response to the realization that falling is not only possible but embarrassingly easy. Then comes the dryness. Water, which has lovingly enveloped these creatures for generations, now disappears the moment they need it most. Moisture evaporates from skin. Gills, used to constant hydration, rebel, and the early tetrapods find themselves in a perpetual relationship with dehydration. Evolution is patient, but land is not. Land welcomes its new residents by immediately trying to dry them out. In this world, survival depends not on wandering freely, but on finding pockets of safety, shallow pools, muddy hollows, shaded crevices, places where moisture lingers just long enough to soothe their aquatic heritage. These microhabitats become focal points, drawing multiple animals to the same shrinking puddles. Not because they enjoy one another's company, but because these are the few zones where life is tolerable. On land, resources are no longer diffusely floating in water. They are clustered, localized, and worth guarding. This is where the earliest form of terrestrial proximity begins. Several tetrapods may rest side by side, each pretending not to notice the others, united only by their mutual appreciation for damp mud. They do not interact in social terms. There is still no communication, no coordination, but they linger near one another with greater tolerance than their ancestors ever showed. Here, isolation becomes a liability. A lone animal risks drying out, getting lost from the last wet patch, or encountering predators without warning. Being near others, loosely, cautiously, provides subtle advantages. The predators of this era are equally new to the land, and they move with the awkward grace of creatures still negotiating their unfamiliar surroundings. Their bodies, built for underwater propulsion, must now adapt to the demands of weight and limb-driven pursuit. They lurk in the reeds, along the banks, or half buried in silt, waiting for a tetrapod to venture too far from safety. Their ambushes are unpredictable, emerging from unexpected angles because land changes the geometry of danger. In water, threats come from in front, behind, or above. On land, they come from anywhere. Early tetrapods, recognizing this unpredictability in the vaguest biological sense, begin remaining closer to one another as they forage. A sudden movement from one creature may scatter leaves or disturb the surface of a pool, inadvertently alerting its neighbors to potential danger. Still, not communication, just the physics of shared space, but valuable nonetheless. Those that linger near others find themselves reacting more quickly to threats, guided not by social intention, but by borrowed awareness. Their bodies continue to transform as they adapt to this environment. Limbs strengthen, ribs broaden, skin thickens to better retain water. Lungs assume a greater role while gills recede into memory. These changes occur over countless generations, each small improvement allowing tetrapods to explore a bit farther from shore, stay a bit longer on land, and rely a bit less on luck alone. But even as their bodies change, land remains a challenging place to thrive alone. Food is patchy, found in clusters of insects, decaying matter, or stranded aquatic creatures. From time to time, several tetrapods converge on the same insect-laden log or the same sun-warmed marsh bed. They feed with a polite distance that says, I acknowledge your existence, but let us never speak of this again. Still, their presence helps them in subtle ways. A shuffle of movement reveals hidden prey. A sudden stillness alerts everyone to potential danger. Multiple bodies reduce the likelihood that any one individual becomes the target of a predator's curiosity. Nights on land bring their own set of challenges. Temperatures drop more sharply than in water. Winds rob moisture from unprotected skin, and darkness reshapes the landscape into a maze of unfamiliar silhouettes. Tetrapods often retreat to the same moist hollows or sheltered pockets to rest. These nighttime refuges do not yet resemble communal living, but they do represent a primitive form of shared space, a quiet acknowledgement that others face the same risks and follow the same narrow corridors of habitability. Over time, these loose associations create evolutionary opportunities. Animals that are less easily startled by neighbors waste less energy fleeing from harmless movement. Those with better spatial awareness more effectively navigate crowded environments. Those capable of tolerating brief proximity to others gain access to limited resources without constant conflict. Land, in its own stern way, begins to favor creatures that can occupy the same space without panic. This is not cooperation, far from it. These early tetrapods do not team up, defend one another, or form deliberate partnerships. But proximity now serves a purpose beyond coincidence. It is a consequence of land scarcity and unpredictability. To step onto land is to accept a world where safety is fragmented and fleeting. And in such a world, creatures tolerate one another not out of kindness, but because the alternative, facing the dryness, the predators, and the unknown completely alone, proves far riskier. Thus begins the slow, quiet shift toward life lived not entirely in solitude. The land remains vast and demanding, yet in certain corners, early tetrapods gather loosely, their fates beginning to brush against one another's. They will not yet form herds. They will not yet cooperate. But they will, for the first time in evolutionary history, learn that surviving on land is a little easier when someone else happens to be struggling nearby. The Carboniferous world thrives under a canopy of towering plants, their fronds and branches weaving a humid green ceiling over the land. Dense forests stretch across continents, fed by warm air and generous rainfall. Swamps spread like quiet inland seas, where giant horsetails and ferns grow in unruly abundance. Life in these ancient landscapes feels sheltered, almost enveloping, until one realizes just how many shadows move beneath the leaves. For this is the age when predators begin to take evolution very seriously. In these forests, predators grow larger, quicker, and far more inventive than their predecessors. Some slice through vegetation with bodies shaped for precision, moving with the kind of intention that makes every small creature wish it were somewhere else. Others stalk on limbs that have grown stronger and more coordinated since the first awkward steps of early land dwellers. Jaws strengthen, teeth sharpen, and senses become finely tuned to vibrations, scents, and the telltale rustle of frightened prey. The world is no longer governed merely by environmental pressures. It is now sculpted by the ambitions of hunters. Prey animals, by contrast, remain thoroughly unimpressed with the idea of fighting back. They are small, soft-bodied, and better designed for fleeing than for confrontation. Many rely on camouflage or burrowing habits, hiding beneath decaying logs or slipping into the soft mud. But as predator efficiency increases, hiding alone becomes a gamble. A lone creature has no distractions to offer, no decoys to mislead a hunter. It is, by default, the most interesting thing in its vicinity, and this is rarely a desirable distinction. Gradually, prey begin drifting into loose associations, not cohesive groups, not organized gatherings, but clusters of animals occupying the same regions for reasons that are suddenly more compelling than they were in earlier ages. The logic is simple. If a predator arrives, it is statistically better for the danger to be distributed across many individuals than concentrated on one. Evolution, with its understated sense of practicality, lets this idea take root long before animals understand the concept themselves. These gatherings emerge most often around safe, resource-rich pockets, ponds that never fully dry, fallen logs that shelter abundant insects, open patches of fungus flourishing on rotting vegetation. Multiple prey species may find themselves sharing the same general territory, not interacting directly, but benefiting from a kind of ambient safety created by mere numbers. One creature hearing a snap of twigs may startle and flee, triggering a chain reaction that inadvertently saves others nearby. The first animal to notice danger rarely appreciates its role as an unwitting alarm system, but its reflexes inspire a ripple of survival. Among these clusters are early reptile-like creatures whose limbs have grown sturdier and whose lungs can better withstand drier environments. They navigate the forest floor in slow, deliberate movements, staying close to zones where they can retreat quickly underground or into protective roots. Their world is layered with hiding places, burrows, leaf litter, tangled roots, and every animal knows that reaching them quickly is more important than understanding what caused the rush. Predators, however, evolve strategies to match this new landscape of prey behavior. Some become ambush specialists, remaining absolutely still until an unsuspecting cluster of prey moves nearby. Others refine their ability to charge with sudden bursts of speed, breaking through the underbrush with startling force. These hunters select targets with precision, often choosing the animal that lingers a fraction too long, while its companions begin to flee. Yet even with these refined tactics, hunters face the annoyance of confusion. In a scattered cluster of prey, individuals dart in different directions, hitting leaves and branches that obscure scents and create misleading vibrations. The predator's focus splinters, breaking its chase into instinctive recalculations. The prey's greatest strength is not intelligence or coordination, but the chaos of numbers. A single slow animal might fall victim, but the others escape through the simple advice evolution gives them. Survival improves dramatically when you're not the slowest thing alone. The forests themselves influence these interactions. The thick vegetation means visibility is poor. Predators must rely on hearing and smell, This makes the sudden rustle of multiple prey an overwhelming sensory event. Mossy ground deadens sound, but dry fronds amplify it, creating an unpredictable acoustic landscape. Every creature must learn to navigate this forest of shifting cues, reading the environment through the noises of others as much as through its own senses. Meanwhile, the Permian period gradually dries the world. Swamps recede, forests thin, and open spaces appear where creatures once relied on dense vegetation to hide. These new landscapes place prey in even more precarious positions. With fewer places to conceal themselves, prey become more attuned to the presence of their neighbors. A lone animal crossing an open plain becomes a beacon, but a small scattering of animals offers at least a distraction. Some begin spacing themselves at distances that allow them to detect a predator's approach while still benefiting from the presence of others. They don't coordinate. They simply respond to the advantages of maintaining a certain proximity. In these open habitats, predators accelerate further, evolving long strides and muscular hind limbs to chase down prey that can no longer simply slip behind a fern. Yet this intensification of hunting pressure reinforces the same quiet truth. Being near others reduces the odds of being targeted. The logic of shared risk becomes not a conscious strategy, but a pervasive selective force, shaping behaviors through countless encounters. There is still no cooperation here, no deliberate teamwork. These animals do not warn one another intentionally, nor do they depend on social bonds. But they survive longer when they move in loose assemblages, when they linger near others who might distract a hunter or unwittingly alert them to danger. Over time, these subtle advantages accumulate. By the late Permian, the shadows of predators stretch long across the land, influencing not only who survives, but how they live. The prey animals have not become herd creatures yet, not in any structured sense. But the seeds are there, quietly germinating in the understory, buried under layers of instinctive decisions and accidental alliances. Life is beginning to realize, in its slow evolutionary way, that danger is easier to face when it has more than one potential target. By the dawn of the late Permian, the land carries a new temperament. Forests have thinned, climates have shifted, and ecosystems pulse with a harsher rhythm. The animals navigating this world must be quicker, more perceptive, and more adaptable than their predecessors. Among them are the early synapsids, ancient relatives of mammals, alongside reptile lineages that test new ecological roles with an almost experimental enthusiasm. This is an age shaped by volatility, where survival depends not merely on instinct, but on the subtle mathematics of proximity. The earliest gatherings begin quietly. A group of synapsid grazers might settle near a pocket of hardy vegetation, each one keeping a suspicious eye on the others. They are not companions. They are not family units. They are simply animals that, through trial, error, and a certain evolutionary resignation, have discovered that existing in predictable, loosely organized clusters reduces the frequency of unpleasant surprises. The world has become too precarious to wander entirely alone. These first groups are fragile things. A cluster of 5 might become 4 without warning, then swell to 7, then drift apart, and recombine as circumstances shift. Members come and go, loyalty non-existent, cohesion fickle at best. A synapsid may graze alongside another simply because that individual has not yet annoyed it enough to justify moving away. Yet despite the tension, the advantages are undeniable. An extra set of ears catching the faint crack of underbrush. An extra set of eyes noticing a predator's silhouette. An extra heartbeat that statistically is more likely to attract danger than one's own. Evolution's logic is subtle here, almost polite. It does not demand cooperation. It merely rewards tolerance. In these early gatherings, movement begins to show patterns. When the sun grows harsh, a small group might migrate toward the shade of a rocky outcrop. When cold winds sweep across exposed terrain, several animals may huddle, not closely, but in a loose formation, where each benefits from the other's presence by breaking the wind and reading the environment more effectively. If one individual chooses a direction, a few others may follow, not out of trust, but because following is easier than initiating a separate path with its own hazards. These are uneasy alliances shaped by necessity. Imagine a group of synapsids resting beneath a tilted slab of stone. They lie spaced just far enough apart to avoid conflict, but close enough that any predator approaching from the side must reconsider its enthusiasm. None of them like sharing the space. Several glare, or the Permian equivalent of glaring, but each silently agrees that disliking one another is still preferable to being eaten alone. As evolutionary compromises go, it is remarkably effective. Some synapsid species develop sensory advantages that complement these gatherings. Their nasal passages grow slightly more elaborate, granting better detection of distant scents. Their ears refine into structures capable of distinguishing the approach of predators across varied terrain: loose gravel, hard rock, brittle vegetation. Yet these senses, impressive though they are, gain even more value when multiplied across several individuals. One animal might catch a scent on the wind. Another might notice movement. A third might freeze at an unfamiliar sound. The group responds to the first alarm, and survival spreads outward through the herd's tension like a crackle of electricity. Predators, too, evolve in this period, and their ambitions push prey animals further toward the security of predictable groupings. Large carnivorous relatives of the Gorgonopsians move with deliberate precision, jaws lined with teeth designed for decisive bites. They patrol territories and study the habits of prey, becoming connoisseurs of patterns. A lone synapsid is a clean opportunity. A small group is a calculation. Predators can still attack, and often do, but the presence of multiple potential targets introduces just enough uncertainty to complicate the hunt. The prey do not know this, but evolution certainly does, and it shapes them accordingly. Feeding behavior becomes another quiet factor encouraging association. Vegetation is patchier now than in earlier lush eras, concentrated in resilient pockets that can support several animals at once. Grazing side by side means not only resource access, but increased environmental awareness. If one creature tenses, The others respond instantly. Sometimes they flee in a unified burst. Sometimes they merely reposition, creating a ripple of subtle adjustments. These collective motions form no deliberate choreography, yet they give the impression of coordinated behavior. In truth, no one is in charge. Everyone is simply reacting to everyone else. Resting patterns shift as well. The first faint sense of rhythm emerges. Groups gather to rest in the same sheltered hollows night after night, forming temporary communities structured not by kinship, but by routine. The consistency itself becomes beneficial. Knowing where others tend to settle gives individuals a reliable place to retreat, a spot that has been incidentally vetted by multiple lives over multiple nights. Familiarity reduces danger, even when that familiarity is built on nothing more than repeated coincidence. As these early gatherings stabilize, even modest increases in lifespan leave measurable evolutionary marks. A synapsid that lives just a little longer has more time to breed. One that avoids just a few unnecessary risks raises its chances of leaving descendants. The payoff is incremental: slightly longer lives, slightly more offspring, slightly greater genetic presence in the next generation. But evolution thrives on small improvements, and these gains accumulate across tens of thousands of generations, gradually shaping species toward group-tolerant behavior. Still, harmony remains elusive. Members squabble. They jostle for the best resting spots. They maintain personal space with the grumpy insistence of creatures who would clearly prefer solitude if it weren't demonstrably unsafe. But even the most irritable synapsid quietly admits, again, strictly on an instinctual basis, that standing near a companion reduces the odds of becoming the day's tragic anecdote. The early Permian landscape witnesses this transformation with the impartial patience of deep time. Nothing dramatic occurs overnight, yet over millions of years, a subtle shift becomes unmistakable. Some animals are beginning to gather in consistent groups, forming patterns that evolution gently rewards. No one likes each other very much, but everyone likes being eaten less. And so the world takes one more step toward the future, where group living will become not just an option, but one of evolution's most successful strategies. By the time the Mesozoic world unfurls in all its sun-drenched enormity, Earth has become a stage vast enough for creatures of astonishing scale. Forests tower with cycads and conifers. Ferns spill across riverbanks in dense carpets, and plains stretch for miles beneath skies shimmering with heat. Into this expansive world step the great herbivorous dinosaurs, animals so large, so enduring, and so transformative that the very ground seems to adjust itself around their passing. And here, for the first time in Earth's history, group living becomes monumental, not just in effect, but in physical size. These herbivores do not gather in modest clusters like the synapsids before them. They assemble in numbers that can be seen from distant hills, in herds that shift the texture of the landscape with every migration. Long-necked sauropods march in loose formations, their silhouettes rising and falling like living archways. Ornithopods travel in broad ranks, their tails swaying in rhythmic unison as they graze and wander. Even armored dinosaurs, sturdy, low-slung tanks of muscle and keratin, often move in parallel or within visual contact of others, forming scattered but persistent networks of shared vigilance. These groups reshape the terrain as surely as rivers do. A procession of giants moves across a floodplain, and the soil churns beneath their feet, opening pathways for water and seeds. Vegetation bends, breaks, and regrows in patterns dictated not by seasons alone, but by the passage of hungry mouths. Plants that can regrow quickly thrive. Those that cannot quietly bow out of the evolutionary competition. The landscape becomes a dynamic mosaic sculpted by herbivorous appetite. Within these herds, each individual owes its survival to something far more subtle than cooperation: the power of numbers. Predators, sleek, tooth-lined, and confident, roam the same environments, but even they hesitate when confronted with a moving neighborhood of enormous bodies. A single herbivore might be vulnerable. 10 are a challenge. 100 become a problem of logistics rather than opportunity. When you can't outrun danger, you overwhelm it with geometry. This geometry takes many forms. Sauropods often travel in elongated files, creating a serpentine line of colossal torsos. From a predator's point of view, this formation is an optical puzzle. Where does one individual end and the next begin? Ornithopods, meanwhile, more agile and numerous, adopt broad arcs or shifting clusters. When startled, they reposition themselves in rippling waves, creating patterns that confuse a predator's depth perception. Ankylosaurs and stegosaurs, though not as strictly group-oriented, still benefit from loosely traveling near others of their kind. A carnivore approaching them must select a path through tails, plates, spikes, and armored backs, each one a discouragement. These formations are not deliberate strategies. Dinosaurs do not hold tactical meetings or distribute roles. Their group dynamics emerge from instinct, habit, and the advantages conferred by staying within sight of familiar shapes. Young individuals often remain near the middle of the herd, protected by the living fortress of adults. Not because the adults consciously defend them, but because evolution has arranged bodies in a way that inadvertently shelters the vulnerable. Movement across the land becomes an event. A migration of sauropods may take days to pass a single vantage point. Their footsteps send tremors through the soil. Their necks sway like slow pendulums. Their shadows ripple across ferns that spring back moments after being pressed down. Orchards of cycads vanish under their feeding, only to reappear weeks later in vigorous new growth. Insects trail the herds, scavengers follow, and predators stalk along the perimeter, wary yet hopeful. For predators, hunting a herd is like chasing a mirage. They pace along the edges, looking for the one individual whose caution lags behind the collective awareness. But herds possess a strange property. Awareness is distributed. One animal may miss a threat, but another, 50 meters away, may catch it in time. A ripple of unease spreads through the group, and within seconds the entire herd is adjusting direction or quickening pace. Even the largest carnivores must respect these mass movements. A single misjudgment could put a predator beneath the crashing weight of panicked animals, and few risks are worth becoming a geological smear. In this world, group living is not merely beneficial, it is transformative. Herbivores that travel together secure more stable access to food, expanding their foraging range without suffering constant predation. They discover water sources not by chance alone, but because the herd's combined movement increases the odds of stumbling upon new resources. Their migrations become ecological events that shape the availability of nutrients for countless other species. Interestingly, the herd itself becomes a kind of ecosystem on the move. Insects follow for the dung. Small scavengers follow for dropped food. Plants evolve seeds designed to stick to passing scales or drift along the airflow created by massive bodies. Even the soil communities shift in response, enriched by cycles of trampling, fertilization, and regrowth. Every movement of the herd is a negotiation with the environment, one that continually redefines what the landscape can become. Within these vast gatherings, individuals maintain personal boundaries, but not rigidly. They jostle gently as they graze, sidestep to avoid collisions, and adjust their positions according to the movements of neighbors. Instinct guides these interactions, ensuring that the herd flows like a river rather than colliding like boulders. The result is a strange elegance, thousands of tons of biomass moving with the slow coordination of a living continent. In these moments, the dinosaurs are not merely surviving, they are succeeding through sheer presence. Evolution has discovered that size is powerful, but size multiplied by number becomes a force that predators, climate shifts, and ecological pressures struggle to oppose. And so the Mesozoic world becomes a place where herds reshape continents, where strength lies not only in muscle but in multiplicity, and where survival follows a simple, unspoken rule. When you can't outrun danger, you overwhelm it with geometry. As the Mesozoic marches onward, something subtle begins to take shape inside the skulls of many herd-living animals. Not a dramatic leap, no sudden appearance of empathy, loyalty, or heartfelt attachment, but a small, persistent refinement of the brain's inner architecture. Neurons wire together in slightly more efficient patterns. Memory lengthens by mere moments. Sensory processing sharpens, not to solve puzzles, but to answer a simpler question. Do I know you? This is the dawn of familiarity. In earlier ages, animals tolerated each other only because the alternative was significantly more dangerous. Now, some species begin to make fine distinctions between the creatures milling around them. A dinosaur glances toward a neighbor and, without understanding the concept, perceives something like recognition. The shape of that crest seems familiar. The way that tail swings has been seen before. The scent, faint as dry grass, is not alarming. This is someone who was here yesterday, and the day before, and the day before that. Not a stranger, not a threat, merely part of the scenery in a comforting way. This newfound ability does not produce affection, not yet. What it produces is tolerance, which in evolutionary terms is almost as valuable. Familiar individuals are less likely to provoke defensive behavior. They do not trigger the instinctive tensions that arise when two animals must decide whether to yield or stand ground. This means fewer skirmishes, fewer wasted bursts of energy, and far fewer injuries caused by misunderstandings in tight quarters. In a large herd, avoiding unnecessary conflict is not luxury, it is survival. To understand how revolutionary this is, imagine a group of herbivorous dinosaurs grazing beneath a grove of conifers. Their interactions are no longer merely about spatial negotiation. Individuals drift toward their preferred cluster of companions, not friends, but known quantities. A juvenile gravitates toward a subgroup it has followed for weeks. Adults maintain loose but consistent spacing with neighbors they subconsciously recognize. They are not forming alliances, but they are forming patterns, and patterns reduce chaos. Memory plays the quiet hero here. Nothing sophisticated, no recollections of events or sentiments, but a system of impressions tied to visual cues, vocalizations, and even footsteps. The brain flags these impressions as safe, allowing an animal to move more calmly and confidently when surrounded by individuals marked as familiar. Strangers, meanwhile, elicit wariness, not hostility, simply caution. This is the earliest form of in-group and out-group distinction, created not by social politics, but by neural housekeeping. As this skill improves, herds become more stable. Instead of dissolving quickly after reaching a food patch, groups linger together for days or weeks. The predictability of group composition means that animals begin anticipating the movement of their neighbors. A slight shift in posture from one individual suggests the herd may soon relocate. A flick of a tail from another hints at irritation, but not aggression. Over time, a rudimentary social vocabulary emerges without any conscious attempt at communication. This stability produces cascading benefits. Coordinated movement becomes easier because individuals are less startled by the presence of those they know. Resting patterns align because trusted neighbors are less likely to jolt awake at the slightest noise. Feeding becomes smoother, with familiar individuals respecting unspoken boundaries more reliably than strangers would. All this reduces stress, an outcome evolution rewards with longer lives and more offspring. Predators notice the difference. A herd composed of strangers is restless, jumpy, and prone to fracturing under pressure. A herd composed of familiar individuals is cohesive, harder to split, and more likely to move as one. For a predator, this cohesion is an obstacle. Coordinated movement means the element of surprise is less effective. It means young individuals remain shielded by predictable arrangements of adults. It means the moment of attack becomes riskier and more exhausting. Predators, unintentionally, select for prey capable of remembering who belongs. Species-specific signals begin to evolve. A particular rumble, a soft bleat, a rhythmic sway of the tail. These signals are not yet communication in the sophisticated sense, but they serve as identifiers, reinforcing recognition and smoothing interactions. A dinosaur approaching a group gives a small, habitual gesture that says, in effect, "I am the same one that walked beside you yesterday. Please do not react dramatically." And the herd, relieved to avoid unnecessary commotion, accepts the message. This early recognition also begins shaping social spacing, Some animals prefer certain neighbors, not because of personality, but because consistent relationships reduce surprises. Over generations, these preferences create loose micro-clusters within the herd, subgroups that travel together, rest together, and drift only gradually over time. They are not families. They are not friendships. They are merely arrangements that work well enough to persist. Still, the seeds of something deeper lie here. The capacity to distinguish individuals opens the door to behaviors that will eventually grow into more complex forms of social life. Cooperation, parental specialization, even rudimentary leadership. None of that exists yet, but the neural pathways that make such future possibilities viable begin forming in these quietly observing creatures of the Mesozoic. Evolution, with its usual efficiency, has no sentimental agenda. It is not inventing friendship for warmth or companionship. It is inventing it because recognizing who belongs is far less costly than treating every encounter as a brand new negotiation. Practicality, after all, is one of life's driving forces, and so on ancient plains and within shaded forests, herds of dinosaurs move with a new kind of cohesion, held together not by affection, but by memory and tolerance. Each creature may still regard others with the emotional enthusiasm of a mildly inconvenienced rock, but it knows the advantage of the familiar. Evolution has invented friendship, but only the extremely practical version. As the Mesozoic world tilts toward its final chapters, Earth begins to change its mood. Warmth that once wrapped the continents like a comfortable blanket starts to fray at the edges. Seasons grow sharper, storms linger longer, dry spells deepen. Temperatures swing in ways that unsettle ecosystems accustomed to gentler rhythms. Though the age of dinosaurs continues, the world they inhabit becomes increasingly unpredictable, nudging both great and small creatures into new patterns of survival, patterns that require them not only to move, but to move together. These shifting climates do not announce themselves loudly. They creep. A season arrives late. A drought stretches past expectation. A coastal flood quells nesting grounds. Grass-like plants begin spreading across open lands, hinting at futures still millions of years away. Forests thin. Rivers braid and wander. In this fluctuating world, food becomes a more mobile resource, appearing and disappearing with a capriciousness that challenges even the most resilient herbivores. And so, without intending to, animals begin turning to collective memory, not the conscious, spoken kind, but the memory written in movement patterns passed from one generation to the next. Some creatures learn that a certain valley holds water late into the dry season. Others discover that a ridge warmed by sunlight thaws before surrounding plains. These discoveries persist because the animals who find and follow these routes survive, and their offspring inherit not knowledge, but instincts shaped by ancestors who walked those paths before them. This is the quiet birth of migration. Groups now travel extended distances, not just within familiar territories, but across vast tracts of land that change character with each shift in climate. The herds that once formed primarily for safety now acquire a new purpose. They become repositories of environmental knowledge, living archives of where sustenance once existed and may exist again. When a herd begins its seasonal trek, individuals who have survived multiple cycles inadvertently guide the younger, less experienced members. Movement becomes a shared tradition, sculpted by hunger and memory rather than social intention. Picture a large herbivorous dinosaur, one of the last of its kind, trudging along a windswept plain. Snow does not yet dominate the world, but cold snaps arrive with unsettling persistence. Vegetation grows sparsely in patches, forcing grazers to keep pushing onward. Behind this dinosaur follows a line of smaller individuals, not its children, but members of the same loose herd, all drawn toward the promise of a place that once held abundance. Somewhere in that crowd, inevitably, is an individual who has walked this route before and whose internal compass twitches at the scent of distant greenery. And though no creature knows it consciously, the herd is relying on that faint tug of instinct. Someone in the group always remembers where lunch used to be. Predators face their own challenges. Cooling climates test their endurance. Prey becomes harder to locate. Territories expand. Some carnivores learn to shadow herds not just for hunting opportunities, but for the simple assurance that wherever herbivores travel, life-sustaining water and vegetation are likely nearby. The predator's paths become entangled with those of their quarry, forming a vast choreography across the landscape, an unspoken agreement that life, in all its forms, must move or perish. As the Cretaceous edges toward its tumultuous finale, climatic instability grows more pronounced. Volcanic eruptions lace the skies with ash, dimming sunlight and altering temperatures. Rainfall patterns fracture. Coastal areas flood, inland areas dry. These disruptions accelerate the need for mobility. Herds that linger in one place risk starvation. Those that wander too boldly risk crossing barren ground. The sweet spot lies in collective movement, where dozens or hundreds of individuals balance caution with persistence, following the faint echoes of successful journeys made long ago. Within these moving communities, behavior subtly shifts. Animals begin to space themselves with more awareness, ensuring that individuals can keep pace even in rough weather. Vocalizations become slightly more varied, not complex communication, but tones that help maintain cohesion through fog, wind, or dense plant cover. A call in the distance becomes a beacon. A grunt from a familiar neighbor means the group remains intact despite the morning frost. These sounds stitch the herd together as it navigates an environment that grows less forgiving with each passing millennium. The late Mesozoic landscape becomes a place of constant movement. Trails carve themselves into the earth as countless feet follow the same winding routes year after year. Riverbanks flatten where travelers drink in great numbers. Hillsides bear smooth tracks where cold season migrations begin their ascent. These pathways persist long after individuals vanish, becoming geological reminders of where ancient hunger once pulled life forward. As the dinosaurs fade and the earliest mammals begin their quiet rise, the climate continues its unpredictable dance. Early Cenozoic mammals, small, warm-bodied, and increasingly exploratory, inherit a world where seasonal pressures encourage collective travel just as much as survival does. Herds of ungulate ancestors trek through cooling valleys, mastering the art of moving as unified bodies. They track the greening of spring, the retreat of snow lines, the reappearance of familiar grazing grounds. Their memories sharpen, their endurance grows, their reliance on one another deepens. And though none of these animals understand the concept, they are participating in something extraordinary: the construction of shared environmental wisdom. Every journey reinforces patterns. Every successful migration strengthens instincts. Every failure prunes paths away. Over time, these instincts become so finely tuned that herds appear to navigate by invisible maps written into their very bones. Group living takes on a new purpose, no longer just safety from predators, but safety from uncertainty itself. The Earth is changing quickly, but herds can change with it. Collectively, they have a better chance of rediscovering old havens, testing new routes, and remembering the places where life, against the odds, still flourishes. In this age of cooling climates and shifting seasons, the future belongs not to the swiftest or the strongest, but to those who travel together, guided by the faint, inherited memory of where the world once offered nourishment, and where it might do so again. The early Cenozoic dawns quietly, as if the world is catching its breath after the tumult that ended the reign of the dinosaurs. Forests regrow in soft waves of green. Rivers realign themselves through fresh sediment. The air warms just enough to coax new ecosystems into motion. And in this recovering world, mammals, once small, shadow-dwelling creatures, step into an evolutionary spotlight they did not expect, but are remarkably prepared to occupy. What sets mammals apart at this moment is not size, strength, or even cleverness. It is attachment, a gentle but powerful thread woven through their behavior. Long before they dominate landscapes, mammals dominate the art of caring for their young. Where reptiles often produce numerous offspring and surrender them to chance, mammals invest deeply in a few. They nurse them, warm them, groom them, and carry them. It is a strategy rooted not in sentimentality, but in efficiency. When the world becomes unpredictable, quality often trumps quantity. This long parental care shapes everything that follows. Imagine a small, early herbivorous mammal resting beneath a canopy of broad leaves. She curls protectively around her offspring, shielding it from the evening chill. This bond lasts not minutes or hours, but weeks and months, long enough for learning to take place, long enough for habits to form, long enough for familiarity to become the backbone of social living. The young watch their mothers forage, navigate terrain, and avoid danger. They inherit not only instincts, but practiced knowledge, passed through presence rather than instinct alone. As these mammals begin to associate in small groups, the tone of their gatherings shifts. A cluster of reptiles may have been a temporary convenience, formed because circumstances required it. Mammals, by contrast, gather because doing so supports their most cherished and most energy-intensive endeavor, raising their young. Safety in numbers now protects not just individuals, but entire family lines. A grazing group offers more eyes, more warning calls, more sheltering bodies during cold snaps. Grazing near familiar individuals reduces stress, and lower stress means more energy for milk production and for growth. Slowly, almost imperceptibly, these groups begin to feel less like anonymous crowds and more like extended families, not in the genetic sense, but in the behavioral one. Their interactions grow layered. A mother nudges her offspring away from danger. A juvenile trots confidently beside an older sibling-like companion. Adults maintain a rhythm of movement that keeps weaker members near the center. These relationships aren't organized by hierarchical rules, but by emotional threads. Comfort with certain individuals, trust built through repeated encounters, and a preference for those whose presence has been reassuring in the past. Mammalian brains, now more complex than those of their ancient predecessors, support these subtle social cues. Regions associated with bonding and attachment develop chemical pathways that reward proximity. Simply put, being close to familiar individuals feels right, so mammals continue doing it. Of course, evolution did not add affection for sweetness or sentiment. It added it because affection happens to be an extremely durable survival tool. As one might say, evolution adds affection, not for comfort, but because it works. As herds form, movement becomes synchronized in ways earlier animals never achieved. A shift in posture from the lead female prompts others to follow. A soft grunt signals it's time to rise and graze. A shared unease spreads through the group when a distant rustle suggests a predator's presence. These cues require not only recognition, but emotional sensitivity, a capacity to read the intentions and tensions of others, even in the absence of elaborate communication. Resting becomes a collective event as well. Mammals often sleep in clusters, pressing their bodies close to share warmth and reduce vulnerability. A dozing adult becomes a living barrier against wind. A drowsy juvenile finds comfort tucked between stable forms. This shared rest cements bonds, allowing trust to accumulate across countless unremarkable nights. A group that sleeps together survives storms, predators, and cold snaps more effectively than isolated individuals. Predators adapt to these emerging patterns with increased stealth and patience. But hunting mammals becomes harder. A cohesive group reacts faster, protects its young more fiercely, and coordinates escapes with surprising fluidity. Even a small herd of early ungulate-like mammals can scatter in a way that forces predators to recalculate mid-chase. Mothers defend their offspring with sudden bursts of courage. Adults circle around alarmed juveniles. The herd pivots like a single entity stitched together by shared instinct. As these behaviors accumulate through generations, herd life transforms from a tolerated necessity into a deeply rooted strategy. Bonds spanning months, even years, become the invisible glue holding groups together. Mammals begin forming long-term social groups where individuals recognize one another not merely by scent, but by memory. memory of shared travel routes, past dangers, familiar patterns of movement. Over time, this emotional infrastructure lays the groundwork for even more complex social interactions. Cooperation emerges casually, then deliberately. A watchful female might guide several juveniles. A seasoned male might lead the way along a known migration path. Though leadership is not formalized, influence grows from experience, age, or confidence, traits that younger animals track with keen sensitivity. The landscape responds in kind. Herds of mammals begin shaping environments through their choices. They trample paths that become permanent features of terrain. They disperse seeds through distant ranges. Their grazing patterns create mosaics of open ground and dense vegetation. The world molds them, and they mold the world, all through the quiet force of collective living. By now, mammal herds truly resemble communities, dynamic, bonded, familiar. Each individual carries a personal history, encoded not only in instinct, but in relationships. Relationships that make life safer, movement smoother, and the future a little more predictable. In a universe where survival once relied on reflex and chance, mammals introduce something new, a life lived with others, shaped not just by proximity, but by connection. By the time mammal herds stretch confidently across plains and valleys, the logic underpinning their survival has acquired a subtle, almost mathematical elegance. Not that the animals know this, of course. They are not sitting around calculating probabilities or debating strategies. Their safety emerges from something far simpler and yet astonishingly effective. There are many of them, and only one of you, dear predator. This is the quiet triumph of numbers, an evolutionary principle that operates without planning, intention, or even awareness. As herds grow larger, a single individual's chance of being the one a predator selects plummets. The world has discovered the dilution effect, and it becomes one of nature's most reliable survival strategies. Consider a herd of grazing mammals spread across a warm, open plain. The air hums with insects. The grass rustles in the wind. And above the horizon, a predator watches, calculating the moment to strike. To the predator, the herd is both opportunity and puzzle. So many bodies. So many moving shapes. So many possible targets. A feast, theoretically. But in practice, a visual labyrinth. The predator steps forward. Muscles tighten. The moment arrives. And the herd responds. Not with coordinated precision, not with rehearsed choreography, but with a spontaneous eruption of motion. Dozens, sometimes hundreds, of individuals launch into flight. Dust lifts, shadows merge, limbs blur. The predator must immediately answer the most important question in its profession. Which one? Unfortunately, all the prey have conspired, quite unintentionally, to make that question nearly impossible to answer. Some dart left, some veer right, some sprint straight ahead, and others zigzag in the manner of animals who have absolutely no intention of being predictable. A predator's carefully planned attack dissolves into visual static, a fast-moving tangle of options. More than once, the hunter lunges toward one shape only for that shape to vanish behind another. Depth perception falters. The eye must track a single target, and yet none volunteer for the role. Safety, it turns out, can be achieved by becoming harder to point at. This phenomenon, predator confusion, is a masterclass in accidental brilliance. The herd doesn't plan to bewilder the attacker. Every individual is simply doing what instinct demands: run as fast as possible. But when many animals run at once, patterns form that no single individual intended. Their movements overlap, rhythms mismatch, and visual cues collide. The result is a kind of biological camouflage made entirely of motion. Predators adapt as best they can. Some sharpen their reflexes. Some learn to focus on individuals behaving slightly differently. A limping calf, a distracted adult, an animal positioned on the fringe. Others attack from angles where scattering is limited. But even with these improvements, the mathematics remain unforgiving. In a large herd, the predator's chance of selecting and successfully capturing a specific individual often drops below the threshold of reliability. Hunting becomes a profession built on frustration. Meanwhile, prey species continue to grow more comfortable in expansive groups. The larger the herd, the less time individuals spend scanning for danger. 100 bodies can produce vigilance far surpassing what any single animal could manage. One hears a rustle, another catches a movement, a third smells something out of place. Each detection spreads through the herd in subtle cues, changes in posture, sudden freezes, ripples of tension. By the time danger becomes obvious, the group has already begun to shift, cluster, or flee. This distributed awareness is not communication in a social sense. It is simply many nervous systems responding simultaneously to shared stimuli. But collectively, it functions like a living alarm network, wide-reaching, immediate, and astonishingly effective. Of course, large numbers come with challenges. Competition for water intensifies. Grazing areas must be vast. Conflict sometimes flares between adults vying for space or dominance. But by now, evolution has equipped many herd animals with behaviors that keep these tensions from escalating too often. Ritualized displays, calming signals, subtle spacing rules. These keep the peace enough that the group can maintain its vast, confusion-inducing size. The landscape responds to these herds with a mixture of tolerance and transformation. Open grasslands become sculpted by constant foot traffic. Waterholes bear crescent-shaped marks where bodies congregate. Wind patterns shift as vegetation changes under the pressure of thousands of grazing mouths. The environment becomes shaped by herds that are shaped by predators, an intricate triangle of influence where the mathematics of survival ripple outward into physical geography. Even the young, playful as they often are, contribute to group safety. Calves learning to run weave between adults, strengthening the unpredictable patterns that will someday confound predators. Their bursts of speed and sudden changes in direction become rehearsals for the confusion clouds they will one day help create. No one teaches them this. They simply practice being alive in a world where motion is protection. And so, the herd moves onward, vast, shimmering, and statistically protected. In the great ledger of evolution, numbers have become as valuable as claws or horns. Strength lies not only in the body, but in the collective presence of many bodies moving with the same simple desire, not to be the one that gets caught. The mathematics of safety are elegant, if occasionally exasperating for predators. For every individual in the herd, survival becomes a probability game, and one heavily tipped in their favor by the simple fact that they are surrounded by others who look exactly as delicious as they do. And in this unspoken agreement between instinct and chance, group living becomes not just common, but essential. As herds grow larger and more stable, a new challenge emerges, one that predators never forced upon them, yet proves just as influential. How to live together without everything descending into noisy, exhausting chaos. When dozens or hundreds of animals gather, each with its own hunger, momentum, and personal bubble of comfort, the potential for conflict multiplies. If every dispute over grazing space escalated, if every movement required renegotiating positions, herd life would collapse under the weight of its own confusion. Evolution, patient and pragmatic, begins to sculpt something subtle, something that does not require symbols, language, or conscious agreement. Social order. Not the rigid hierarchies of future primates, nor the elaborate leadership rituals of birds and elephants. These early arrangements are quiet, almost invisible. Reflexive patterns of who steps aside, who stands firm, who leads movement, and who drifts to the edges. Nothing is decided, and nothing is voted upon. Yet the patterns persist, smoothing the friction of group life in ways that make herds not merely possible, but durable. At its core, this order begins with spacing. Even among the most peaceful herbivores, personal space is a cherished commodity. Individuals do not like being bumped, crowded, or brushed against without warning. Such contact sparks tension, and tension sparks unnecessary energy expenditure. A costly activity in a world where survival already demands plenty of effort. So herds evolve a form of spatial choreography. Each animal keeps a careful distance, adjusting with tiny steps or shifts of weight to maintain a comfortable buffer. These adjustments appear almost casual, yet together, they create a moving lattice of bodies that rarely collide. The spacing is not uniform. Dominant individuals, often larger, older, or more assertive, inhabit the positions that suit their needs. The best grazing patches, the most direct routes to water, or vantage points that minimize threats. Subordinates yield subtly, stepping aside or curving their path without fuss. A single tilt of the head, a quiet flick of the ears, or a confident stride communicates enough. The message is simple. I'm taking this spot. You may prefer another, and in most cases, the other obliges. Dominance does not emerge from aggression alone. It emerges from predictability. Animals learn through repetition, which neighbors are inclined to insist on priority and which prefer to avoid confrontation. Over time, these micro-interactions crystallize into a structure. Herd members memorize the personalities of those near them, who bluffs, who stands firm, who startles easily, who moves first. This memory, combined with instinct, forms the earliest seeds of what could be called hierarchy, though no rules are written and no individual actively seeks a throne. For example, consider a large ungulate ancestor approaching a prime grazing patch. Several others already feed nearby. Without thinking, each animal evaluates the newcomer. Is this one assertive, familiar, easily deterred? Each decision is instantaneous. One steps aside, another doesn't bother. A third drifts to a less contested tuft of vegetation. No conflict ensues, because each participant already knows how the moment will unfold. The script is written not in intention, but in repeated experience. Movement through the environment follows similar dynamics. When a herd begins to travel, whether toward water, shade, or new feeding grounds, there is no command. Instead, a handful of confident individuals simply begin walking. Those who trust their instincts fall in behind them. Those more cautious wait until the majority has shifted. Youngsters watch for cues from adults. Stragglers close ranks once the direction becomes obvious. Before long, the entire group is in motion, aligned without meetings, debates, or announcements. It is a masterpiece of unspoken coordination, achieved entirely through subtlety. These hierarchies offer profound advantages. Conflict decreases dramatically, sparing energy and preventing injuries that could spell disaster in a predator-filled world. Grazing becomes efficient, as dominant individuals choose routes and subordinates flow around them without clogging movement. Watering holes, often risky and crowded, become more manageable with predictable patterns of access. Even rest is organized through habit. Individuals settle where they feel secure, often near neighbors whose presence has proven reliable. The young learn these rules simply by existing alongside their elders. A juvenile steps too close to a dominant adult, receives a mild shove or a sharp look, and remembers the boundary henceforth. Another tries to take a prime resting hollow and is gently displaced. Social education happens without intention, passed through posture, proximity, and the occasional corrective nudge. Predators, observing from afar, may mistake this organization for the product of intelligence or leadership. But the herd does not follow a leader in the human sense. It follows patterns, emergent behaviors etched into the instincts of each member. If a dominant animal dies, the hierarchy does not collapse. It simply rewrites itself through countless small interactions until the structure stabilizes once more. Occasionally, these systems experience disruptions. A young male reaching maturity may test boundaries. A drought may concentrate many herds into the same shrinking resource pool. Yet even in these moments, violence is rare. Ritualized threats, hoof stamps, head tosses, deep calls resolve most disputes. Actual combat is reserved for only the most serious confrontations. Evolution, always counting calories, strongly favors animals that know how to win arguments without needing to fight them. And so, without language, without law, and without leaders, herds become orderly societies, held together by the quiet consistency of behavior. No one votes, but everyone somehow agrees, not because agreement is sought, but because harmony is cheaper than discord. In this silent governance, group living transforms once again, from a crowd of individuals to a cooperative constellation of roles and rhythms. A living system of etiquette evolves, shaped not by intention, but by the timeless efficiency of instinct. By the dawn of expansive grasslands, the relationship between animals and their environment undergoes a profound shift. No longer are landscapes merely the backdrop against which life unfolds. They become pliable, changeable, sculpted by the steady movements of countless hooves. Herds, once simple gatherings of animals seeking safety, now rise to the level of ecosystem engineers, reshaping the very ground beneath them through constant motion and steady appetite. Grasslands themselves owe much of their global success to these massive grazers. Before herds became widespread, many regions were dominated by mixed woodlands, patches of scrub, and tangled vegetation that grew taller and thicker each season. Fire occasionally cleared these spaces, but without consistent disturbance, forests would return, crowding out the short, sun-hungry plants waiting patiently at the soil's edge. Then came the herds, wave after wave of grazing mammals sweeping across the land with the casual determination of creatures simply looking for their next meal. Hooves press into soil, cracking crusts and opening pockets where seeds and water settle. Teeth tear grasses low, encouraging plants to invest energy below ground, developing massive root networks that make them resilient in the face of drought and grazing alike. As herds return again and again, grass species that thrive under repeated disturbance expand across continents, gradually pushing back the forests. The landscape adapts, mostly by giving up and becoming grass. Yet it is not only the plants that change. The soil itself transforms under the influence of herds. Constant trampling compresses some surfaces while churning others, creating a dynamic patchwork of textures. Fertilization arrives in steady doses, delivered without ceremony across the plains. Each deposit enriches the ground, fostering the growth of nutrient-loving species and supporting microbial communities that flourish in the wake of animal movement. These microbes, in turn, help recycle nutrients more effectively, accelerating the productivity of the entire ecosystem. Even fire regimes evolve in response. Grasses dry quickly, forming vast mats of fuel that ignite during storms or heat waves. But instead of burning forests to ash, the fires sweep through grassy plains at low intensity, clearing old growth while sparing most roots. Many grasses even rely on these cycles, sprouting vigorously after flames pass through. Herds contribute indirectly by maintaining open environments where fires spread easily, yet threaten little beyond the plants adapted to withstand them. It becomes an elegant cycle. Animals shape the distribution of grass. Grass shapes the distribution of fire, and fire shapes the future of both plants and animals. With landscapes increasingly dominated by broad, open vistas, herd animals face new evolutionary pressures. Vastness demands endurance. Food spread across enormous distances demands efficient movement. Predators, now exposed without the cover of dense forests, must adapt as well, relying on speed and stealth in equal measure. In this open theater, The dynamics of survival shift once more, and the herds, already powerful in numbers, become even more influential. As herds roam, they carve paths through the land, pressing trails deep into the soil. These trails become highways of ecological exchange, used not only by herd animals, but by predators, scavengers, birds, and smaller creatures seeking safe passage through tall grasses. Over time, these routes direct water runoff, alter drainage patterns, and even influence where new vegetation grows. A seemingly simple track worn into the earth becomes a subtle architect of future habitats. The presence of herds also changes the very shape of plant communities. Grasses that can tolerate repeated grazing or grow quickly after disturbance dominate, while slower, more delicate species retreat to protected niches. Some plants evolve spiky defenses or bitter chemical compounds to discourage nibbling. Others adopt the opposite strategy. They grow soft and abundant, practically inviting herbivores to trim them, knowing that regular grazing helps them outcompete taller rivals that would otherwise overshadow them. In this reciprocal relationship, evolution begins to flow both ways. Animals shape plants, and plants shape animals. Herd-living mammals develop specialized teeth, digestive systems, and jaw structures to deal with abrasive grasses. Limbs grow long and sturdy to cover ground efficiently. Sense organs sharpen to detect predators across sweeping horizons. And the herds themselves swell in size, their collective presence giving rise to the ecosystems that best suit their needs. The broader environment responds in unexpected ways. Birds follow the herds, feeding on insects stirred up by hooves. Scavengers track migrations, filling their bellies on leftovers. Burrowing animals take advantage of softened soil. Even the wind participates, carrying seeds across spaces left open by grazing and trampling. Each species becomes a thread in a tapestry woven by the daily routines of the herds. Rainstorms transform differently now. Water cascades across plains where forests once stood, collecting in shallow pools shaped by hoof prints or filling depressions carved through years of migration. These temporary waterholes become hubs of activity, nurturing amphibians, insects, and thirsty travelers. The land grows more interconnected, dotted with microhabitats born from the rhythms of animal movement. Over time, this mutual shaping of life and land creates unexpected resilience. Grasslands withstand drought better than forests. Herds moving in vast networks track rainfall patterns and keep ecosystems in motion. Their presence helps prevent the stagnation of vegetation. They stimulate regeneration simply by being themselves. In these ancient plains, the world feels alive not in spite of the herds, but because of them. Their endless footsteps set the tempo. Their grazing sets the boundaries for which plants flourish. Their migrations distribute nutrients, shape soils, and guide the fates of countless other species. Group living, once a response to predators, now becomes a planetary force, sculpting continents through millions of tiny interactions repeated across millennia. The herds do not know they are shaping Earth's future. They only know the next patch of grass, the next path forward, the next motion of the group. Yet through their collective presence, they transform the land into something new, a world that moves in harmony with the rhythm of their lives. Across the broadening grasslands and cooling uplands of the later Cenozoic, herd life undergoes yet another transformation, one not carved into the soil or mapped across continents, but quietly assembled in minds. Until now, herds have survived through instinct, coincidence, and the sheer advantage of numbers. But as mammals refine their senses, memories, and emotions, a new phenomenon rises at the heart of collective living: shared intelligence. Not the kind that belongs to a single brain, but the kind that flickers through many bodies at once, knitting individuals into a creature far greater than the sum of its parts. This intelligence does not speak. It does not plot. It does not strategize in any conscious way. Instead, it reveals itself through signals, glances, and the finely tuned choreography of movement. A herd standing quietly on a sunlit plain may look tranquil, but beneath the surface lies a continuous exchange of information, some deliberate, most accidental, all meaningful. Consider a group of grazing mammals scattered loosely across a slope. Ears flick in different directions, tails switch rhythmically, and bodies shift as individuals interpret the landscape. Most of these gestures are about comfort or balance, yet some convey subtle messages. A raised head means attention. A stamp of the hoof means irritation. A rapid exhalation might signal uncertainty. These cues travel outward like ripples across water. One animal notices another's tension, adjusts its own posture, and unknowingly passes the message along. Soon, a faint undercurrent of alertness sweeps through the herd, even before any sound of danger reaches them. Communication here is not language, but alignment. Each body reflects the emotional state of its neighbors, and through countless repetitions, the herd learns to respond to patterns rather than individuals. When the wind shifts, bringing with it the scent of something unfamiliar, the first animal to detect it will stiffen. That stiffness spreads, not because others smell the same thing, but because they trust the posture of those who react first. It is the earliest version of collective decision-making. Uncertainty, multiplied, becomes clarity. As these interactions refine, herds begin moving with uncanny cohesion. A slight turn of one individual's head nudges those nearby to reorient. A short, soft grunt encourages the young to follow. A few steps taken by a confident adult set the direction for dozens behind. No command is given, yet direction emerges. Nobody's in charge, yet somehow it all works. Predators test these dynamics constantly. A stalking cat or pack of canids creeps close, hoping to isolate a vulnerable target. The herd senses the approach not as a single event, but as a mosaic of micro-reactions. A calf edging closer to its mother, an adult pausing mid-chew, a pair of juveniles suddenly aligning their bodies in the same direction. The predator is not detected by sight alone. It is detected by the pattern of awareness cascading through the group. When the moment comes to flee, the herd does not debate or hesitate. Dozens of bodies accelerate almost simultaneously, turning what would be individual panic into a smooth, rolling escape. Even the young, prone to impulsiveness, are swept into the momentum, guided by the flow of older animals whose bodies provide both shelter and direction. The stampede is not chaos. It is precision born from simplicity. Each animal follows the nearest safe space, and through that simple rule, order emerges out of urgency. Over time, these systems grow more sophisticated. Different species adopt distinct repertoires of signals tailored to their environments. Prairie dwellers may use sharp whistles that carry across open ground. Mountain herds rely more on posture, since echoes can distort sound. Some species flick their tails in coded rhythms. Others communicate tension through tremors in their muscles or shifts in pacing. None of this requires planning. It unfolds naturally as animals discover which signals elicit useful reactions from their neighbors. Decision-making becomes distributed. If one experienced individual senses a distant storm, its subtle shift in direction may redirect the entire herd toward safer terrain. If another detects fresher grazing ahead, it may walk there with quiet certainty, drawing others forward. The herd does not follow leaders so much as it follows confidence, an evolutionary shortcut that works astonishingly well. Successful decisions spread. Unsuccessful ones fade quickly, remembered only in avoidance of certain scents, sights, or routes. And so the herd operates like a network. Decisions arise in multiple places, are tested instantaneously through movement, and stabilize into collective action. This kind of intelligence does not reside in any one brain. It lives in relationships, the spacing, habits, and shared expectations that each animal reinforces simply by existing alongside others. Youngsters learn this intelligence through immersion. A calf watches how adults respond to shifting winds. A juvenile mimics the cautious steps of others when navigating rockier terrain. Trial and error teaches them how closely to follow, when to lag behind, and how to interpret the soft signals adults exchange. By the time they reach maturity, they become part of the system themselves, contributing their instincts to the living mind of the herd. Such collective awareness proves invaluable not only during danger, but in daily life. Herds adjust grazing routes based on subtle cues, changes in plant scent, soil firmness, or the behavior of insects reacting to weather changes. They choose resting sites with surprising thoughtfulness, often selecting ground that offers good visibility, moderate shelter, and escape routes known to the group. These choices are not deliberate calculations. They emerge from countless small decisions made by many animals over many lifetimes. The result is a kind of group-level wisdom, built from individual perceptions continuously shared and reinforced. And so, across the world's vast plains and open highlands, herds begin behaving like single organisms composed of many moving parts, each animal a neuron in a sprawling, ambulatory mind. Their success arises not from complexity within individuals, but from simplicity repeated across many bodies. It is intelligence without pride, strategy without leaders, cooperation without intent. Nobody's in charge, yet somehow it all works. We arrive in the living present, where grasslands shimmer under high sun. Forests breathe in layered harmonies of light and shadow, and deserts unfold in quiet, wind-swept tapestries. Across these landscapes roam the descendants of those ancient experiments in group life, modern herd animals who carry within their bodies the accumulated wisdom of hundreds of millions of years. They do not know their lineage, of course. They are simply doing today what worked for every ancestor who lived long enough to leave something behind. Their story is not dramatic. It is not a tale of sudden victories or heroic feats. Instead, it is a testament to steady, collective persistence. A strategy so reliable, so elegantly simple, that evolution has returned to it again and again. Modern herds take many forms. Plains filled with antelope move like liquid across the horizon. Zebra groups ripple in striped patterns that seem to bend the sunlight itself. Wild horses run in arcs that mimic the contours of the land. Caribou journey across cold expanses with such determination that their hoofbeats feel like seasonal punctuation marks on the earth. Each species embodies a different version of the same ancient principle. Stay close, stay aware, and let the group carry the burden no single individual can bear. These animals live in worlds shaped by constant motion. Food shifts with seasons. Water recedes and returns. Predators test their boundaries daily. In these demanding environments, herd living offers a kind of gentle insurance. A lone animal may possess speed or cunning or endurance, but a herd possesses something far more powerful: continuity. When predators approach, many eyes detect the threat. When drought dries a familiar valley, many memories, some older, some younger, guide the group toward distant resources. When storms rise suddenly, bodies cluster instinctively, forming a shared refuge made of muscle, breath, and ancient habit. No formal leader stands at the front of these gatherings, yet decisions emerge with surprising clarity. A few animals begin moving toward greener ground, and others quickly fall into place. The change ripples outward until the entire group shifts like a great, unified organism. From above, it resembles a murmuration frozen into heavier bodies, patterns shifting not with flight, but with hoof steps and quiet resolve. It is the legacy of instincts perfected through countless environmental tests. The predators who approached too quickly, the dry spells that punished hesitation, the fertile valleys rediscovered through persistence. The success of herds lies in their quiet redundancy. If one individual falters, others remain. If one memory fades, another persists. If one idea, embodied not in thought but in movement, fails, the group's larger patterns absorb the mistake. A herd is both vulnerable and resilient, delicate in its dependence on the environment, yet robust in its ability to respond to change. It is an organism with many centers, none privileged, all essential. This collective endurance shapes modern landscapes just as earlier herds transformed ancient plains. Grazing animals maintain the open grasslands that define entire biomes. Their wandering disperses seeds crucial for plant renewal. Their paths channel water, sculpting small basins and microhabitats that nourish birds, insects, and amphibians. Even their resting places become ecological fingerprints, fertile patches enriched by the simple rhythm of life lived in numbers. Predators, too, owe much to the quiet success of herd animals. Wolves, lions, hyenas, big cats, they all evolved in response to the challenges that herds present. Their cunning, their teamwork, their patient strategies all reflect a world in which prey is well defended, not by armor or venom, but by one another. Thus, the dance continues. Predators press, prey adapt, and ecosystems pulse with the tension that drives evolution forward. Yet for all the drama we might imagine in these interactions, most of herd life is wonderfully uneventful. Hours pass in grazing, resting, and moving at a careful pace. Youngsters explore the boundaries of safety, darting and leaping until an adult gently corrals them back toward the group. Dust rises softly from the earth. Birds follow at safe distance. The sun arcs across the sky, and the herd continues on, unhurried and untroubled unless the world demands otherwise. This is the underrated heart of herd success: stability. Social bonds, whether loose or tightly knit, give individuals the emotional grounding they need to navigate a world full of uncertainty. Comfort is not a goal, but an outcome. Stress diminishes when familiar bodies surround you. Rest comes more easily when the group's presence promises security. Young animals grow with confidence simply because they rarely face the world alone. Humans often look for grandeur in evolutionary stories, a flash of brilliance, a leap of intelligence, a transformative invention. But herd living achieved greatness through subtlety. It is not loud. It is not glamorous. It does not boast. It simply works. Again and again, across continents and epochs, it works. And evolution, ever the stoic engineer, never promised excitement, only continuity. In that continuity lies a quiet beauty, the knowledge that survival does not always require spectacular adaptation. Sometimes it requires nothing more extraordinary than staying close, staying attuned, and letting the group guide the way. Modern herds are living echoes of a principle older than grass, older than continents in their current shapes. A principle that has watched worlds rise and fall and has persisted through it all. The quiet success of staying close endures as one of evolution's most graceful achievements, written across the living earth in hoofprints, shadows, and the soft murmurs of animals who thrive not alone, but together.